Okay, today I'm going to be going over method number 3, which is solving log and ln equations. When we're solving log equations, you'll typically see one of two types of problems, and I've got them both worked out here, the first two examples in your notes. So the first thing you need to know is that when logs are on the same side of the equal sign, like they are in this first example here, where I have these two logs being added, then I'm going to condense them using the laws of logs. So if you remember, the condensing properties tell us that when two logs are being added, I can condense them by multiplying what's inside. So we condense these two down into one, and then we multiply the inside of one times the inside of the other. Now you can write the 4x minus 3 first if you like. I just always like to put a singular number in front of the parentheses when we multiply. Mathematically, multiplication would be the same. After we condense it, now what I have is log base 4 of, and when I simplify here, 8x minus 6 equals 2. Now the x is stuck inside the log here, and I need it to get out of the log if I want to solve. The easiest way to do that is to switch to exponential form. So we're going to start with the base of the log, base 4, to the power of 2 equals 8x minus 6, and that's what I've got right here. And now we can simplify. We know that 4 squared is 16. And then from here, we're going to solve for x. We need to isolate x. So by adding 6 over, dividing both sides by 8, and we get x equals 11 over 4. Now, in solving logs, you do have an extra step, which is to check. And the reason that we get a check is because we can never take the log of a negative number. This is actually the reason why logs have asymptotes, because we can never plug in a number that will make the inside of the log negative. So you just have to check the inside. You don't have to fully solve the problem. You just look inside of any logs where there's an x. So here there's just a 2. We don't care about that one. We just look at the 4x minus 3. And I make sure that when I plug my solution in, that the part that's inside the log is a positive value. So this is positive 8. That's all I need to know is that it's positive. So there's a good answer. Now there is a second case you might see, and that's like what we have over here. In this case, I have the log. Remember, if there's no base, it's base 10. So log base 10 of 5x equals log base 10 of 2x plus 9. Kind of like with exponentials, if I have two logs that are the same base equal to each other, then I know that whatever's inside of those logs must also be equal. So we can drop the logs and we can just set their insides equal to each other. So we have 5x equals 2x plus 9. From here, I'm going to solve for x by getting the x's to one side, so subtracting 2x over, and I get 3x equals 9. Finally, divide by 3, and we get x equals 3. Now still, because we started with logs, we have to check. If I plug in 3 for 5x, that's 15, and that's positive. And if I plug in 3 for 2x plus 9, that is also 15 and also positive. So on both cases, this answer works. Let's try one together now. Practice A. In this practice, the first thing I see is that I have two logs that are on the same side of the equal sign together. So step 1 will be to condense those logs into one singular log. These two logs are being added, so I can condense them into one by multiplying what's inside. So that's the 2 and the x plus 8. So this will condense to 1 log base 7 of 2 times x plus 8. And then I'll just bring down equal to log base 7 of 30. All right, now that these logs on the left are condensed, I'm going to look at the equation. I have log base 7 of 2 times x plus 8 equals log base 7 of 30. Hey, in this question, I've got log base 7 on both sides of the equal sign, and so now we can drop the logs. I'm left with 2 times x plus 8 equals 30. All right, so now we get to just solve for x. The first thing I need to do is get rid of these parentheses, so I will distribute that 2. And I get 2x plus 16 equals 30. Next thing I'm going to do to solve for x is subtract 16 from both sides. And I get 2x equals 14. And then I'm going to divide both sides by 2, and I get x equals 7. Last thing I need to do once I have my answer is check. There's only one log with an x inside, so that's the only one we have to check. 7 plus 8 is 15, which is positive. So we are good. We've got a good answer. All right, let's try B. In question B, I only have one log on one side. So there's no condensing, and I can't drop the logs. So this is an example where we have to switch to exponential form. I'm going to start with the base of the log because that becomes the base of the exponential. Base 6 to the power of 1 is equal to 2x minus 1. All right, now that we're in exponential form, we're ready to solve for x. 6 to the first power is just 6. Next thing I would do to solve for x is add 1 to both sides, and I get 7 equals 2x. Then I would divide both sides by 2, and I get 7 halves equals x. Now we still need to be checking because this is a logs problem. So we're going to plug in 2 times 7 over 2 minus 1. 2 times 7 over 2 is 7, minus 1 is 6, and that is positive. So we are good. All right, in part C, I have 2 times log base 3 of x equals 4. Think, what would you do first in this problem? There's actually 2 right answers. Just depends on how you want to approach it. If you thought you could condense 2 into the log, you definitely can do that first. If you thought divide both sides by 2, that's also an option as well. I'm going to choose to divide both sides by 2 because that'll just keep the problem a little bit easier. But either way, you should get the same answer. So I'll divide that 2 away so that way I get the log by itself because I cannot switch forms if I have that 2 out front. Now I'm ready to switch to an exponential. So starting with my base of 3 to the power of 2 equals x. All right, simplify. So 3 squared we know is 9. And there's nothing else to solve for, so x equals 9. Plugging it back in here, if I plug in 9 for x, well, that is a positive number. So that's a good answer. All right, part D. I've got one log, but if you notice that log is not by itself. So while there's no other logs to condense it with, I do need to isolate that log before I'm ready to switch to exponential form. When we isolate, we do like we've done in other types of problems where we use order of operations in reverse, or as some of you call it, SADMAP. So I'm going to start by adding 5 to both sides. And I get 3 times log base 2 of x plus 1 equals 12. All right, the next thing I need to do is cancel out that 3 out front. So I will divide both sides by 3. And I get log base 2 of x plus 1 equals 4. Now that I've isolated the log, I have just one log on one side, so I'm going to switch to exponential form. Starting with the base of the log, that becomes the base of my exponential, to the power of 4 is equal to x plus 1. All right, now we're going to simplify and solve. 2 to the 4th power is 16. Bring down the x plus 1. And now solving for x, I would subtract 1 from both sides, and I get 15 equals x. Last step is to plug it back in. We only have one log here with the x. 15 plus 1 equals 16, and that is positive, so we are good. All right, in question E, I only have one log. It is the ln of x. So I need to first isolate that log. I'm going to subtract 3 from both sides, and I get 2 ln x equals 4. Now I need to finish isolating the log, and I'll do that by dividing that 2 from both sides. Since it was 2 times the log, we get ln of x equals 2. And now that I have just one log, I need to switch to exponential form. Now remember, ln is a special log. It is log base e. So e is the base to the power of 2 equals x. So x is equal to e squared, which if we plug e squared into our calculator, you should have an e button, which you can square. It approximates to 7.389. That's a positive number, so when I plug it in for x, we will have a positive inside the log. That is a good answer. All right, in part F, we have 2 logs that are on the same side of the equal sign. So step 1 is going to be to condense those 2 logs. Now these 2 logs are being subtracted. So the condensing rules for subtracting 2 logs is that we turn them into one log using division. So we're going to have x plus 1 divided by 3. And then I'll bring down the equal to 1. Now that I have the logs condensed, I notice there's only one log left on one side of the equal sign. So I need to switch to exponential form. Starting with the base of the log, which is a base 4, to the power of x is equal to x plus 1 over 3. Oops, why did I write x there? All right, this is supposed to be a 1. So 4 to the 1st power equals x plus 1 over 3. Now I can simplify. We've got 4 equals x plus 1 over 3. 4 to the 1st power is just 4. And now solving for x. Now when we solve here, the first thing I want to do is cancel the denominator. I do have to do that before I cancel out the plus 1. And I know I've been saying do order of operations backwards, but the problem here is that x plus 1 is stuck in parentheses. So we have to get rid of the division before we can get rid of the parentheses. So that's why in these cases, we actually get rid of that division first by multiplying both sides by 3. So I get 12 equals x plus 1. Now I can subtract 1 from both sides, and I get 11 equals x. Last step is to check. There's only one log with an x inside, so that's the only one we have to check. 11 plus 1 is 12, which is positive. We are good to go. All right, 3 more examples here we can do together. Starting with G, I see that I've got a log and a log on the same side of the equal sign, so those 2 I will condense. These 2 logs are being, oops, I didn't mean to erase. They're being added together. So with log properties, I can condense them into one log base 12 by multiplying x times x plus 1. Bring down that equals 1. Now I only have one log, so I need to switch to exponential form. My base is 12, so 12 to the power of 1 equals x times x plus 1. All right, we're going to do some simplifying on both sides here. 12 to the first power is 12. On the right side of the equal sign, I need to distribute the x. So x times x is x squared. X times 1 is 1x. And now, notice there are two x's in your equation. Not only that, but we have an x squared. Think back to Unit 2. What are some of the solving methods we know for a quadratic equation with x squared? Probably some of our favorite ones is factoring. So we're going to try to factor first. In order to factor, I need the equation to be equal to 0. So I'm going to subtract the 12 over because we want to keep x squared positive. I get 0 equals x squared plus x minus 12. Now I can set up big X and try to factor to solve. Negative 12 goes on top and b is on the bottom by itself. Two numbers that multiply to negative 12 but add to 1 would be 4 and negative 3. So we get 0 equals x minus 3 times x plus 4. Now we need to solve each of these factors. And I get x equals 3 and x equals negative 4. All right, we've got two answers, but we need to check them. So we'll start with 3. If I plug in 3 here for x, that'll be a positive, so that's good. And if I plug in 3 here for x, I will get 3 plus 1, which is 4. That's positive, so that's good as well. Let's check the other answer of negative 4. If I plug in negative 4 plus 1 is negative 3. That's not good. So negative 4 is not a good solution. X equals 3 is our solution. All right, in question H, I have ln of x plus 3 equals 2 ln of 4. Now, in this problem, I have logs on both sides of the equal sign. So I would really like to drop the logs, but I cannot drop them yet, since one of the logs has a number in front of it because of this 2. But think about some of the properties we've learned. Do we know how we can move that 2 so it's no longer in front of the log? Remember that if you have a number multiplying the log, you can move it to the exponent inside of the log. So this is actually the ln of 4 squared. Now that helps us because once I just have the log equals the log, we can drop the logs and we get x plus 3 equals 4 squared. Simplifying this, x plus 3 equals 16. I need to finish solving for x, so I'll subtract 3 on both sides, and x equals 13. Final step is to plug in for x just to make sure it stays positive. 13 plus 3 equals 16, which is a positive value, so that is a good answer. All right, in our last example together here, I've got 2 logs on the same side of the equal sign, so I'm going to condense them first. When I condense these 2 logs, remember that the base stays the same. So because this is base 10, we're going to get log base 10. And then they're being added together, so I'm going to condense them using multiplication. When I multiply these, I get x times x plus 48. I rewrite it in this form, in this order, just because that's easier for me. If you don't like doing that, you can write it in the normal order. And now that I have just one log on one side, I'm ready to switch to exponential form. So we'll start with the base of the log. Remember, if there's no base written, we know it's base 10. So we've got 10 to the power of 2 equals x times x plus 48. All right, I'm going to first simplify what I have here. So 10 squared is 100. And then x times x plus 48, I get x squared plus 48x. All right, we've got another example here where we have an x squared. I'm going to start by trying to factoring it. To factor, I need to get the equation equal to 0. So I'm going to subtract 100 here so that it equals 0. And I have to subtract it from both sides. So we get 0 equals x squared plus 48x minus 100. And now I can set up big X. I need two numbers that would multiply to negative 100 but add to a positive 48. That could be 50 and negative 2. So 0 equals x minus 2 times x plus 50. Now I need to solve both of these. So x minus 2 equals 0. X plus 50 equals 0. I get x equals 2 and x equals negative 50. Now we need to check them both, so plugging them back in up here, this is just the log of x. So if I plug in 2 for x, that's positive. But if I plug in negative 50 for x, that's a negative number inside of the log. So negative 50 is not a good answer. X equals 2 is our final answer here.